So we are knocking out 13.4 and 13.5 today.
Yeah,
we sure are. We're going to go a little bit more than what you need to know in Algebra 2. But I want y'all to start thinking about in regards to your next class that you take, whether it be honors pre-cal or stats or CP pre-cal, depending. Remember, stats you can only take if you're a senior, going to be a senior. But really start thinking about some of the stuff that I'm going to show you, because I'm going to show you how to graph by hand, which is something you'll do in pre-cal. Right now, you could get away with plugging it in the calculator and calling it a day, okay? But start thinking about that next class, even though you might be sitting at an A or a B in here. An A or a B means honors pre-cal. But if you're like, I think I got to an A or a B because I got to use a calculator on everything and I just plugged everything into my calculator, you know that what you have done in the class is maybe not as pure as what it would have been if we didn't have computers and online tests and calculators for everything. So just kind of keep stuff like that in mind when you start thinking about the next class you're going to take. I don't want you to show up to pre-cal thinking it's a cakewalk, okay? But I also don't want to scare you away from pre-cal as well, because it's a good course to take. But just start thinking about stuff like that. I know grades right now are just totally different than the grades have been the highest they've ever been in all of my honors algebra 2 classes, which is definitely different. So just kind of keep that stuff in mind as you move forward. So I'm going to show you how to graph sine and cosine and do transformations to this. Again, probably way more extreme than you need to know sitting in an algebra 2 class. All right. But I'm trying to prepare you as we move forward. Okay, so you'll need your unit circle as a little bit of a reference, just to kind of have out. We're going to use the same points around the unit circle, because me personally, if you're looking at your unit circle, I would rather, it might be different, I would rather graph zeros and ones and negative ones instead of root 3s over 2, root 2s over 2, and 1/2. Does anyone right now can rattle off what root 3 over 2 equals?
Yeah.
Okay. I mean, we could figure it out, but if I said, can you show me where 1 is? And you're like, right there. Okay. So again, I'm going to show you how to graph these, but to make them to those zeros and ones, we got to do a little bit of extra work to get there, okay? So let's look at the sine function first. So you're going to have off to the side, if this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. I'm just putting those ordered pairs that we have already learned. And of course, this is 2 pi also. Okay, and for the parent function, we're going to set up our x and y axis the same for both sine and cosine. So I'm going to set up my x and y axis using pi over 2, pi, 3 pi over 2, and 2 pi. Just like those are the spots that I picked on that circle as well. I'm just going to go backwards with those same amounts, but negative. highest my order of paired numbers go? What's the highest number I can see there? Just on the order of pairs.
1.
1. What's the lowest?
-1.
-1. So with every single graph you're going to draw, they're going to look the same. The only thing that's going to be different is how you label your x-axis and how you label your y-axis. Okay? They're all going to look the same, except the x-axis and the y-axis are going to be different. Because I could put a 4 there where 1 is. Is that same drawn to scale where 1 is versus where 4 would go? No. Okay? But, again, it all depends. I know normal graphing, we don't usually put like 1, 2, 3, 4, 5, 6, 7, 8, and so on. All right? It's just understood. These, you cannot just assume. You have to put something down there. Okay? So let me show you how easy this is once this is all set up. All right? So we are interested in, we're graphing sine. Sine is my what value? Y. Okay? So I might highlight or underline all of my y values. Okay? Just because it will be visually easy for me to see. Okay? So here we go. Let's look at 0 here. At 0 pi, or 0 in general, what is my y value there? 0. At pi over 2, what's my y value? Wait, I wrote that backwards, didn't I? Let me fix that one. There we go. Okay, sorry. At pi over 2, what is my y value? 1. At pi, my y value is 0. At 3 pi over 2, it's -1. And then back to 2 pi, which is 0. I can go backwards with that same information. If I go backwards pi over 2, I get -1. Backwards pi, it's me 0. But if you see the pattern, you just keep going. Okay, so now we have a wave. Okay. Some teachers teach it where they say like a little saying with it, where they're like, this is 0 high, 0 low, 0 high, 0 low, 0 high, 0 low. And I keep going with that pattern, if that makes sense to you. Okay. But that pattern does keep going. And it will go for cosine as well. The only thing different about cosine, of course, it's going to look a little bit different than that. Have the same shape, but it'll look a little bit different. Okay? So, who remembers from their science classes what amplitude means? Hey, what is it?
The height that the wave reaches.
Okay, so in this particular case, what would be your amplitude?
1.
1. Okay. Some people look at it from the highest point to the lowest point and divide by 2. Some people look from the highest point to the resting spot, I've heard people call it. Okay. But in any case, your parent function, your amplitude is going to be 1. And we're going to learn 2 here in a second. And it's always going to be the number in front of sine. Positive, of course. Amplitude is always positive. Okay? So then the period of the function is what distance does it take for this graph to complete one full cycle, okay? So I need to figure out when I can take a whole piece of the graph, if I can cut it off there, take it and copy paste it over and over and over again, what is that distance? So if I went from 0 to 2 pi, I could copy and paste this and the graph would keep going. Now, this is, whoops, definitely messed up now. This is not drawn to scale, but I should be able to, again, copy paste it over here and copy paste it again outside of here, okay? So that's what the period of the function means, okay? What distance am I looking at that I can take it and I can almost cut it off, and then I can actually repeat that pattern over and over again to complete the rest of the graph, okay? So this particular distance here is just from 0 to 2 pi. And that will be your period of the function for your parent function of sine. Okay? What distance it takes to complete one full cycle of the graph that I could actually take, cut it off, and move it if I needed to. Okay? I couldn't do 0 to pi because that only gives me the top part. I don't have a graph that looks like just a bunch of mountains, okay? I don't have a graph that looks like that, okay? So I would need that extra piece that continues the graph for me. So it would be what distance is it that would create a repeat in my graph, okay? All right, let's look at some information about sine. Transformations are still the same, except they are called different things in trig. Okay? You're still going to have a vertical stretch and compression, but it's now called the amplitude. Okay, so if you think about the amplitude, if it's that distance, sometimes they'll be bigger, sometimes they'll be smaller. Your amplitude is always the absolute value of A. Always positive. The period of the function can change if there's a B value in front of X or theta. If there's a number of some sort in front of X, or if they use theta, then you would put 2 pi over B. And B is the number of cycles in the interval from 0 to 2 pi. So how many of those little loop-de-loops do I have to do from 0 to 2 pi? The first one we did, it only is 1. You're still, and we'll talk about these tomorrow, you still have left and right. It's just not called left and right anymore. It's called a phase shift. The good news is you still have up and down, and that's still called up and down, okay? That still moves the graph up and still moves the graph down. Okay? All right, so let's check out these 3 graphs. I know they're hard to read, so I'm going to kind of point out some stuff to you. This is 2 pi here. This is 2 pi here. And this is just pi, okay? what they are wanting to know, how many of the little squiggles, how many cycles is going to fit in between 0 and 2 pi? That's the first question they ask. How many of those complete cycles am I going to have to fit between 0 and 2 pi? Then I want to know the amplitude and the period of the function. Okay, so go ahead and look at those. I know they're not right in front of you and you can't trace things, but look at them to see how many cycles it takes from 0 to 2 pi, and then the amplitude and the period of the function. Okay. Okay, so let's look at the first one. I know that one complete cycle is that much right there. I can take that little squiggly line right there and copy paste it all the way through. Okay, if I only did the top part, I would only have the top part. If I only did the bottom part, I'd only have the bottom part. I need both the top and the bottom. Okay, so how many of these squigglies fit between 0 and 2 pi? How many?
3.
3. Okay, so I have 3 cycles. What is my amplitude? 2. So then the period of the function, this one is a little difficult just because I know this is not literally right in front of you. Okay? What?
2/3.
2/3, or in other words, 2 pi over 3, because we're dealing with pi now. So for those of you who don't see that, here is pi. This is a distance of 1 pi. Okay? Here's pi right here. That's why I tried to tell y'all that 2 pi was there. So they have it sectioned off into thirds. They have 1/3, 2/3, and then 3/3. So if this right here is a distance of 2/3, and the period of this function is 2 pi over 3. That distance of 2/3 pi, if you will, is what I'm going to pick up and move over and over and over again. Okay? So how many cycles did I get through from 0 to 2 pi? I'm sorry?
1/2.
1/2. Because that's not the full thing. I'm missing the bottom part. So I only got through half of it from 0 to 2 pi. Okay, what's my amplitude here? 1. And then the period of the function, so if it takes me from 0 to 2 pi to get half of it, how much is it to get all of it? 4 pi. Okay, so if it takes me 0 to 2 pi to get the first part, I need another 2 pi to get me the rest of it. So 4 pi would be the period of the function. Okay. And then lastly, if I have this right here, so if it takes me 2 of these to get to just pi, how many is it going to take to get to 2 pi? 4. So what's the amplitude here? 1/2. Okay, we only go up as high as 1/2. And then the period of the function. So this is sectioned off by 1, 2, 3, 4. So this took up 2 sections. So what's the period of the function? Pi over 2. So I understand this is not physically in front of your face where you can like look really closely at it. I know it's up on a screen, so it might be a little bit more difficult to see. But if you need to rewatch this video, of course, it's all going to be posted. So you can see it up close and personal instead of up on a screen. Any questions on those 3? Yeah.
So this is more of a question of just like in general,
Uh-huh.
like how does sine, which is hypotenuse over opposite, right?
Opposite over hypotenuse.
How does that like transform into this, or how do you get that on like here?
It doesn't necessarily transform to that because sine is not restricted to just opposite and hypotenuse. That is only for right triangle trig. You have to actually have a right triangle.
So this sine is different than that sine?
No, it's the same. So if you would have had your if you would have had the full geometry class, they taught you those special right triangles where it was like the 30, 60, 90 and the 45, 45, 90. Then they had the sides that went along with that. You can get that whole unit circle, those ordered pairs from knowing the special right triangles. What I'm saying is that when we're graphing these, that has nothing to do with the opposite and hypotenuse stuff because we're not dealing with we're not looking at necessarily a right triangle. Yeah.
Will they ever give you the cycles, the amplitude, and the period, and then ask you to graph it?
Oh, they can do all the stuff. They can do all the things. And that's pre-cal. So like I said, I'm exposing you what I'm going to show you next. You can plug into the calculator, and I'll show you how to do that because even if you know how to plug it in the calculator, you know how to use it is the problem. But no, I could give you an equation. I can give you just the amplitude, period, and phase shift and all that stuff, and you have to graph it. I could give you a graph and you tell me all that information. I mean, there's all kinds of stuff, just like there's all kinds of stuff with a quadratic. This is just a whole new ballgame. Yeah. Any other questions? So like I said, is it necessarily important that I teach you how to do this by hand? No. Will you need to know how to do this when you go to pre-cal, and this is what pre-cal is going to look like? Yes. Okay, I'm going to show you how to plug this in the calculator afterwards, and show you how to do it correctly in the calculator. So that way in the world of Algebra 2, you know how to do this stuff, but I'm also showing you in the world of pre-cal what you're going to be exposed to, okay? So first what I want to do is I want you to tell me the amplitude and the period of this function. So just go ahead and write down the amplitude and the period of the function. Okay, what is my amplitude? Just 2. Remember, absolute value, no negative. The period of the function is 2 pi over b, which in this case is 2 pi over 3. Okay, so if you think about it, what used to take 2 pi to get the whole thing in there is now going to take 2/3 pi, okay? So what used to take a whole long journey there is now going to be like squished, okay? So that doesn't mean we're going to set up our x-axis the same way we set it up for the parent function. Things are going to be a little bit different, okay? So how we're going to set that up, we're still going to use our zeros and ones. We have to do a lot more work at the beginning, but then it helps us graph the easy numbers like zeros and ones and negative ones. I could plug in any value I wanted to, but then I'd have to graph things like √3 over 2 and √2 over 2 and stuff like that, and I'm really not in the mood for that. Okay? So, how do I figure out what my x-axis is going to look like? Okay? So what I'm going to do is I'm going to take the period of my function every single time, and I'm going to divide it by 4. Why 4? I got 4 things going on over here with my zeros and ones. You notice how when we set up our original graph, we had pi over 2, pi, 3 pi over 2, and 2 pi. That's 4 things, okay? So we're always going to divide by 4, okay? Which means 2 pi over 3 times 1/4, which is 2 pi over 12, which is pi over 6. What does that mean? That means what I go by on my x-axis. And it's really cool. Like I said, if you have to do a little bit of extra legwork at the beginning, the actual graphing part is super simple. Okay? So if you're asking me to divide by 4 to make my life easier when I get to the graphing part, I have no complaints. Okay? So if I go by pi over 6, I have 1/6, 2/6, which is pi over 3, 3/6, which is pi over 2, and then 4/6, which is, oh, convenient. There's the period of my function, 2 pi over 3. Okay? All right, so I'm going to show you how this works by starting with 0 over there. I'm going to look at my original equation. -2 sine of 3 times 0. Well, 3 times 0 is just 0. So what is sine at 0? Again, if it helps, underline your y's. You get 0. And 0 times -2 is just 0. So I stay there. Okay, let's plug in pi over 6. So -2 sine of 3 times pi over 6. Well, 3 times pi over 6 reduces to what? Pi over 2. Wow, that's convenient. And not the next step. So if you set this up correctly right here, you're going to keep going around that circle like we've been doing. So like I said, if I have to do a little bit of work at the beginning to make this really simple, then I'm going to do it, okay? So if I plug in pi over 6, that got me at pi over 2. And my value there is 1. So 1 times -2 gets me -2. Okay? And then from there, if I have my x-axis set up correctly, I just continue the pattern. I go up, and this is 2, because we said our amplitude was 2, and then back down. And now, I have my graph. Could I keep plugging in values? Absolutely. If you're like, I don't know that I trust how I set up my x-axis, I could plug in pi over 3. Pi over 3 times 3 gets me pi. Sine at pi is 0. 0 times -2 is 0. 0. I could plug in pi over 2. I get 3 pi over 2. Sine at 3 pi over 2 is -1. -1 times -2, +2. So I could keep going if I wanted to. Or if I know the pattern, I can do that as well. Okay. So again, could we straight plug this into our calculator? 100%. But this is the type of stuff and then some that you're going to be doing in pre-cal. Okay. So let me show you how to use the calculator correctly. Okay, so we've been working in radians, so go ahead and change your mode in your calculator to radians. And then I want you to type in -2 sine, and then 3, you can just use x, and then don't press anything after that. Y equals, type all that in. Okay. Once you have that typed in, and that's a -2 there for my virtual kids, that kind of blacked out there. You're going to hit zoom, and look how it says Z trig. We want that. Okay. So hit 7. And a graph appears. Notice, nothing is on the x-axis. Nothing is on the y-axis. You could all day assume that one hash mark means 1 and one means another one means 2 and on from there, but not necessarily, okay? So if it was more of like a visual, like multiple choice situation, you could probably ballpark it off of the graph that your calculator gives you, okay? But let's make it a little bit more substantial, all right? So I don't know if y'all are aware, in your calculator, you can mess around with the table that you have. So go to second table set, which is the window. Second table set, which is window. Notice how I've already changed mine, but independent, change it from auto to ask. Okay, change it from auto to ask. And you'll have to know how to come back to this to change it back, because during a normal test, I don't want you freaking out that your table's gone away. What you're doing is you're telling your table that normally pops up with like all the numbers for X, you're saying, hey, hold on a second. I want to tell you what to tell me. Okay. So now go to your table. I already have stuff in mind. Sorry, let me clear it out. So now your table is completely blank. So like I said, normal graphing, if you're like, my table didn't show up and no numbers are showing up and you start freaking out, go to your second table set just to double check that the independent's back to auto. Okay. So within your table, let's say you did not even know how to set up that x-axis. If you knew how to set up that x-axis, you could simply start typing in stuff you know, like pi over 6. Oh, all I plot is -2. Cool. Got it. Or if you typed in pi over 3. Whoops. Oh, I plot 0 at pi over 3. Got it. Okay. But let's say you didn't know how to set up that x-axis and you just wanted to go around the unit circle. So yes, I probably would have typed in pi over 6. Oh, that's an easy one. Pi over 3. Got it. Maybe I'd type in pi over 4. So that's also on my unit circle. Ooh, I got a decimal. That's okay. If you're using a calculator, that's totally fine. If I'm doing this by hand without a calculator, I want to stay away from the decimals. Okay? But I could keep asking my calculator all different types of questions like, hey, what's the value at this? What's the value at that? And keep going from there. Another way you can do these, go back to your calculator and go to your graph. And you can go to second calc. See how option 1 is value. Click enter. And it just says x equals. Okay. Well, I want to know what y equals if I type in pi over 6. Oh, it told me it's at -2. So that's another way to do it. If you wanted to do the table set, or if you wanted to do using the value thing on your calculator. Yeah. Are you in radian mode? I'll do it. Yeah, you have to be in radian mode. Now, if you look at their x-axis and it says degrees, make sure you're in degree mode. Okay. But you've got to know how to use your calculator if you're going to do this without doing it by hand. Okay. Now, what I would do, I would just make a habit of taking your calculator, going back to your table set, and make sure you change it back to auto again, so that way you don't freak out as soon as you hit y equals in your or your table, sorry. and your values aren't there and you're like, what do I do? Okay. All right. So that is your sine graph. You can do all kinds of transformations with it too. Now let's take a quick break and we'll do our cosine graph.
Banana stick. Yeah. I think this is a compensation one.
Okay. No, we're in radians. Notice how you type in pi? That means radians. Okay, let's type that in radians. And then did you do zoom click? Zoom. we're still gonna do more examples of it. But you're asking how to write the equation? So if the period is pi, we find it by 2 pi over b, and they're telling you that it's pi. Not 2 pi over pi. If we want 2 pi over b to be pi, what does b have to be? Okay, so then b is 2, so that's what it will be 2x or 2 theta or whatever. And then now, see, this was only set up that way for that one problem we did. So you're gonna set that up, if the period was pi, if we divide that by 4, so we're gonna go by pi over 4.
Bless you. Zoom time.
All right, let's check out cosine function. I'm still gonna use that same 0, 1s. And I'm gonna still set up my X and Y axis like I've been doing. So if we are looking at cosine is our x values. Okay, we start at 0. What is cosine at 0? 1. Cosine at pi over 2? 0. And then I keep going. -1, 0, 1. I can go backwards.
Yeah, you can.
And it looks like a W. So it looks very similar, and some people argue that it's the sine function but shifted. Not necessarily, they're different, but I can see how that's an argument there. Okay. Your amplitude is still 1, and the period of your function is still 2 pi, sorry. Because I can still take this amount right here, and if it was actually drawn to scale, I would be able to pick that piece up and move it, and I'd get the rest of the graph. Okay, so that's all the same. The process was still the same, figuring that out. Except instead of looking at our y values, we looked at our x values. Okay. Do y'all see how if I took the period of the parent function 2 pi and divided it by 4, you'd get pi over 2? And that's why I'm always setting it up pi over 2s. Because it's always taking us around that circle of our zeros and ones. But that never changes. You don't ever divide by a random number. It's always going to be 4. Okay, same rules apply to cosine. The only thing that's different from the last slide and this slide, or the one that looked just like this and this one, is that instead of sine, it says cosine. Okay, A is still your amplitude, the absolute value. Period is still 2 pi over b. B is the value next to x, or theta. And b is still the number of cycles in the interval from 0 to 2 pi. That is the exact same stuff. Yes, sorry.
So do C and D still affect it horizontally and vertically, or are they just kind of there?
Yeah, so we're not even, I can't remember, I'll have to look at my notes again for tomorrow. I have a hard time with like the algebra 2 trig side of things and the pre-cal side of things, because in my mind I'm like, I'm ready to tell you everything you need to know about this, but then I'm like, whoa, they're just an algebra 2, you know. But actually to go left and right is not just looking at C. It's C over B, which is weird. I know. And they call it a phase shift instead of just left and right. But that's what you're doing. You're going left and right. But yes, D is still up and down. Yeah.
Maybe this is a hard question to answer considering like our limited knowledge of this
Yeah.
stuff, but like,
I'll still answer it.
what actually is cosine and sine and tangent? What are they?
What do you mean?
Like, what does
They're functions,
yeah, but like, what
Yeah.
does it represent?
all kinds of stuff.
Okay.
Yeah, I mean, it really does. Like how I can tell you to find cosine of 30 degrees. What does that do for me? Okay, that's finding, you're finding information about something beyond probably what you'll learn in pre-cal. I mean, there's all kinds of stuff that goes past that. What we're doing here it can relate to so many different things out in a world that's way past what some of y'all will ever experience. Wavelengths, sound waves, all kinds of different stuff like that. But besides it just being a function is what your world is right now for this stuff. Just like the quadratic function is. But the quadratic formula is one of those, or quadratic function is one of those that we're able to figure out if an object goes flying in the air, when it hits the ground and when it goes to the highest point. Sine and cosine, it's talking about different things too. It's like when we're talking about sound waves, wavelength, and like all the different kinds of weird stuff that goes way beyond even my knowledge. So there's a purpose and a thing for all of it. It's just what level you'll reach to see it.
Okay.
Mm-hmm.
I still barely understand what like log is.
Coming back to the logarithms. Did you research it?
I mean, like I know what like it does now, but like I really do not understand this.
You understand about how it gets the variable out of the exponent and all that stuff?
Yeah, I understand how to plug it in, but I don't
Not
understand.
necessarily how to plug it in, what it does for you.
Well, yeah, I know that.
Well, if you know that, then that's what it is.
Well, no, I'm talking more about this stuff now.
Yeah,
I don't understand this at all.
I don't want to get to that level of math to understand it, but I also cannot come to grips with the fact that you're basically telling me I won't know.
I won't tell you won't know.
Well, but that,
If
but
you
you're
talk
saying
to
that
if you
like,
talk to high school me, I would have told you there's no way I'll be a high school math teacher. 100%. No, like if you talk to
Yeah.
high school me and you would say, "Hey, you want to be a high school math teacher?" I'd be like, "Dream on."
You want to work with a
look
bunch
where
of
I am.
snot-nosed brats?
So I'm not saying that you
Yeah,
won't
I have a
ever
very
see
keen
that. I'm just saying that it sometimes gets to that level where it's like beyond even what I know, and I have a math degree.
I'm being honest.
that's where that comes in.
Well, the numbers disappear once you get out of calculus.
What?
Exactly.
That's not. Is it math anymore if there are no numbers?
Yeah,
What?
I had the same argument. Don't worry. Same argument. Okay.
Just writing a full-on like sentence. And,
No, it's paragraphs is what it is.
oh my
But
goodness.
you don't like reading. Is that why you don't like reading? Is because you have to write so much?
No, I don't mind writing.
Well, but you're sick of looking at words.
No, like everything past Calc 3 at for the math degree, at least at UT, it was Calc 3 is the prerequisite into the math degree. Then after that, it's no longer it's all analytic stuff.
Can you give us an example of like what that means? Like what, like a problem that you would see? And like,
I've told y'all that I had to prove why 1 was bigger than 0.
Oh,
Then it was
that in
like,
Calc
prove
3.
why if A is, if set A is this and set B is this, but empty set this, and then prove why. And it was like,
What?
yeah, exactly.
Oh, just,
Everyone hear me when I say this. It's literally all in who you know in college. Find you a good friend that helps you through all of the things. Because that's what I had a guy that was a friend of mine that he was a double major in physics and math, and he understood all that stuff. We were best friends because he told me everything I needed to do to get through all of those analytic classes. But yeah, it's some tough stuff. I had a professor that and all of his notes, like all the proofs he did in class and his notes were the test. So what I do, I took all the proofs that he did in class and I wrote them 1,000 times until I had them memorized. And then he handed out the test and I just put words on a paper and aced every single one of them except for one where he decided to do different proofs. The whole class failed that test. But all the other ones we aced
Why so much of math graphing? What do you want me to do?
because they're functions.
Okay.
Every function has an input and output. So you're going to graph. All right, moving on. All right, so we're looking at cosine, which are my x values. My amplitude in this case is 3. The period is still 2 pi. So I'm still going to fill this out as pi over 2, pi, 3 pi over 2. That didn't change. If the period of the function doesn't change, and we're not really in the world of phase shifts just yet, you're just going to keep your x-axis the same, okay? You're going to get to a point where you can have no period change, but you can shift the graph left and right, so then that does change your x-axis, okay? So I would take this one step at a time. If you need to write it down on paper, go for it. If you can do it in your head, that's fine too, okay? So if I have 3 cosine, and I'm going to start with 0, then plus 1. So then I say, what is cosine at 0? 1 times 3, 3. Plus 1 is 4. So I'm up at 4 if I plug in 0. That's what?
That's not PEMDAS.
Yeah,
Oh, okay, I'm just stupid. Okay, I was thinking backwards.
PEMDAS is what he's trying to say. Please excuse my dear Aunt Sally.
I'm done. Okay. My math teacher back in like 4th grade was like extremely country, so.
All right, so let's plug in pi over 2. What is cosine at pi over 2?
0.
0. 0 times 3 is 0. 0 plus 1, then we're at 1. I can keep going. If I plug in pi, what's cosine at pi?
-1.
-1 times 3?
-3.
-3 plus 1. Oops. I can plug in 3 pi over 2. Cosine of 3 pi over 2 is 0. 0 times 3 is 3, back up to 1. Now I can see how this pattern works. And I have my graph. Okay, so once you have that all set up, you're just plugging in like you would a quadratic function or a linear function or a cubic function. It doesn't matter. You're plugging in an input value, you're going to get an output value. Okay. Again, the level you're at, you'll probably have a calculator if I had assumed. You had to graph these, plug it in the calculator, and follow those steps. But I want to show you how to do this without a calculator. Okay? All right. So for the next problems, I don't want you to graph them. I just want you to tell me the period and the amplitude. Okay? So just tell me the period and the amplitude of each one of these functions. All right, who's got my first one for me? My amplitude and the period of the function. Jenna?
1/2 and pi.
Okay. So when we do 2 pi over b, and I'm just showing it for this one in case y'all need to see for the rest, I have 2 pi over 2. So yes, the period of my function is just pi. All right, who's got number 2? Yeah, go ahead.
3
Okay,
and 4 pi.
and 4 pi. So we end up having to multiply by the reciprocal, which then makes it 4 pi. All right, number 3. Yeah, go ahead.
1 and 2 pi over 3.
Excellent. What about number 4? Number 4? Okay, Katie?
Is it 1/4 and 2?
And 2, yeah. So this is the weird part. We're so used to like not having pi in a lot of the things that we do. And then now it's like we've seen nothing but having pi in there. So when it disappears, we're like, whoa, 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 where'd pi go? Okay. So yeah, 2 pi over pi, pi's cancel, we're just left with 2. Okay. What about number 5? Okay.
2 and 4 pi.
2 and 4 pi. Remember, amplitude's always positive. Always, always, always positive. Don't put that negative there, even though it is in front. It's still a reflection of the graph, but the amplitude itself is still 2, even though it reflected. Okay, and number 6. Okay.
2 and 1/3.
And 1/3. So if I do 2 pi over 6 pi, pi's cancel, 2 over 6 reduces to 1/3. Good job. Okay. So again, if we can really find the period and the amplitude of the functions, we can know what the actual parent function looks like. I feel like that's a win in regards to Algebra 2, the basics. Okay. Step up honors, step up going to honors pre-cal. I just wanted to expose you to some more things. Okay. So homework tonight, make sure y'all do the 13.4 and 13.5.